What if I told you? The next global blackout might not start on Earth, but 150 million kilometers away. Imagine waking up one morning. No internet, no GPS, no banking systems, flights grounded, power grids collapsing city by city, satellites silent. And the scariest part? It wouldn't be a cyber attack. It wouldn't be war. It would be the sun. Right now, above your head, the sun looks calm. Bright, steady, life-giving. But beneath that glowing surface is a violent ocean of plasma, constantly twisting and snapping magnetic fields like cosmic rubber bands. And when those magnetic fields snap hard enough, they release something called a solar storm. A solar storm begins with a solar flare, an intense burst of radiation from the sun's surface. These flares are often linked to dark patches called sunspots, regions where magnetic energy builds up to extreme levels. Sometimes, alongside a flare, the sun launches a coronal mass ejection, a massive cloud of charged particles traveling through space at millions of kilometers per hour. If that cloud is aimed toward Earth, we have a problem. It usually takes 1 to 3 days for a coronal mass ejection to reach us. During that time, scientists at organizations like NASA and NOAA monitor the sun 24/7 using satellites such as the Solar Dynamics Observatory and the DSCOVR spacecraft. They track the speed, density, and magnetic orientation of the incoming storm. Because here's the key, not every solar storm is dangerous. If the storm's magnetic field aligns opposite to Earth's magnetic field, it can punch through our planet's natural shield, the magnetosphere. That's when the real chaos begins. When the charged particles slam into Earth's magnetic field, they create geomagnetic storms. The sky lights up with auroras, beautiful waves of green, purple, and red light dancing near the poles. It looks magical, but underneath that beauty, invisible electric currents surge through the ground and into long metal structures, especially power lines. And that's where modern civilization becomes fragile. Our power grids are built with transformers designed for normal electrical loads, but geomagnetic storms can induce powerful currents that overload and permanently damage these transformers. And here's the terrifying detail. Large transformers are not easy to replace. They can take months, even years, to manufacture and install. In 1859, long before smartphones and satellites, Earth experienced the most powerful solar storm ever recorded, the Carrington Event. Telegraph systems across North America and Europe sparked, failed, and even caught fire. Operators received electric shocks. Some telegraph systems continued working even after being disconnected from power, fueled purely by geomagnetic currents. Now imagine that same level of storm hitting today's hyper-connected world. Satellites would be among the first casualties. Solar radiation can damage their electronics, knock them off orbit, or increase atmospheric drag, causing them to fall. GPS signals could become unreliable. Communication satellites might fail. Weather forecasting could go dark. Airlines would reroute flights away from polar regions to protect passengers from radiation exposure and communication blackouts. Financial markets, which depend on precise GPS timing, could experience synchronization failures. Internet infrastructure relying on undersea cables might face disruptions due to geomagnetically induced currents. And hospitals, emergency services, water treatment plants all depend on electricity. In 1989, a powerful geomagnetic storm struck Earth and collapsed the Hydro-Quebec power grid in Canada within 90 seconds. 6 million people were left without electricity for 9 hours. That storm was far weaker than the Carrington Event. Scientists estimate that if a Carrington-level event happened today, the economic damage could reach trillions of dollars globally. Recovery could take years in the worst-hit regions. And here's the suspenseful truth. It's not a matter of if, it's when. The sun operates on an approximately 11-year solar cycle. During solar maximum, sunspot activity increases, and the likelihood of powerful flares and coronal mass ejections rises. We are currently in solar cycle 25, and activity has been ramping up. That means the probability of extreme solar storms is increasing. But here's the twist no one talks about enough. Solar storms don't need to be record-breaking to cause serious damage. Our modern world is far more dependent on vulnerable technology than ever before. A storm weaker than Carrington could still create cascading failures. And there's another threat. High-energy solar radiation storms that can reach Earth in just minutes after a flare. These can endanger astronauts in space, damage satellites instantly, and interfere with radio communications before we even have time to react. So what are we doing about it? Space agencies and governments have developed early warning systems. Satellites like the Solar Dynamics Observatory constantly watch the sun's surface. The Space Weather Prediction Center issues alerts when major flares or coronal mass ejections occur. Power companies in some countries have protocols to temporarily shut down vulnerable equipment when severe geomagnetic storms are forecast. Engineers are working on hardening transformers and building more resilient grids. Satellite manufacturers are designing radiation-resistant electronics. Some nations are even including solar storms in national risk assessments alongside pandemics and cyber warfare. But here's the uncomfortable reality. Global preparedness is uneven. Many regions lack robust grid protection. Replacement transformers are limited. Supply chains are global and fragile. A severe storm could disrupt manufacturing, shipping, fuel distribution, and communication simultaneously. And unlike a hurricane or earthquake, you cannot see a solar storm coming from the ground. The sky might look perfectly normal. That's what makes it so psychologically chilling. Picture this scenario. A massive sunspot rotates into direct alignment with Earth. Telescopes detect growing magnetic instability. Suddenly, an X-class solar flare erupts, the most powerful category. Within minutes, radiation storms begin. Within hours, satellites start experiencing anomalies. 1 to 2 days later, the coronal mass ejection arrives. Auroras appear as far south as tropical latitudes. Social media fills with stunning sky photos at first. Then transformers begin to fail. Regions lose power. Communication becomes patchy. Emergency services are overwhelmed. Without electricity, fuel pumps stop. ATMs stop working. Refrigeration fails. Supply chains freeze. Modern society runs on invisible systems. Electricity, data, timing signals. And solar storms attack all three at once. And here's something even more unsettling. Scientists studying ice cores and tree rings have found evidence of ancient solar particle events far stronger than anything recorded in modern history. One event around 774 AD appears to have been significantly more intense than the Carrington Event. If a storm of that magnitude struck today, it could overwhelm even hardened infrastructure. The sun is not just a stable star. It is a dynamic magnetic engine capable of extreme outbursts. But don't panic, there's another side to this story. Earth's magnetic field is a powerful shield. Most solar storms are deflected harmlessly. Severe events are rare, and awareness is growing. Governments, scientists, and engineers are taking space weather more seriously than ever before. The same technology that makes us vulnerable also helps us monitor and predict these events. We are not helpless, yet we are exposed. And that dual reality is what makes solar storms one of the most fascinating threats in the universe. They are natural, inevitable, beautiful, and potentially devastating. The sun gives us life. It powers our climate, drives photosynthesis, and makes Earth habitable. Without it, we would not exist. But under the wrong magnetic conditions, that same star could temporarily switch off the digital civilization we've built in just a few centuries. The question is not whether the sun will erupt again. It will. The question is whether we'll be ready when it does. Because somewhere out there, on the surface of our star, magnetic fields are twisting right now. Building pressure, waiting. And the next time they snap, it won't just light up the sky. It could light up the grid and then turn it off. You're watching Infinite Cosmos,